In this session, we will have a look at now how we use the CPT programming tool to program the Sedona controllers, how to get started. First of all, let's have a look at the network architecture. The CPT programming tool runs on your PC, what we just installed. What we then need to do is to connect the CPT tool PC to the Sedona controller, whether it is a Sedona 30-point controller, Sedona 20-point controller, or 32-point controller. In order to connect the CPT tool to the controllers, we have to be in the same IP network. So the first 3 digits of the computer IP address has to be the same as the 3 digits of the controller IP. As default, the SDC-20G controller comes as an IP address 192.168.10.11. So in that case, our computer has to be something like 192.168.10. Anything else than 11 in order to be able to connect to the SDC-20G controllers. If you don't know how to change your IP address on your PC, there are many good YouTube videos regarding how to change the IP address on a PC. So I would recommend to have a look at one of those, if and when required. Okay. So now what we have is the CPT tool installed on your PC, and what we need to do is to start the CPT tool. It opens the window where we have 2 buttons on the bottom. We have the open application and another button which is the last controller that we are connected to using the CPT tool. We can now just click this button on the CPT tool and it pops up the windows to open the Sedona. First thing is the protocol socks. It's always the protocol socks. We leave it as it is. Then we set up the IP address of the controller. In this case is 192.168.10.11, which is the Sedona 20G controller. Port number for the socks is 1876. We always leave that unchanged. Username is admin and a password field we leave it empty. When the CPT tool connects to the controller, it uses the Sedona files that have been downloaded with the CPT tool. As default, it uses the default Sedona folder, and you don't normally have to change, but you can, if you have multiple installations of CPT tool, for example, you can use another Sedona folder. But we will come back to that later on about what is the Sedona folders and how to upgrade the libraries, and which are called kits. Okay, now what we do is press OK, and this now connects to the SDC-20G controller. Once we have connected to the SDC controller, we now have a workspace with the CPT tool. The CPT tool has been divided with a number of different sections. On the left-hand side, we have a tree structure that illustrates the programming objects within the SDC controllers. Below that, we have a library area. The library area basically contains all the kits or the application object libraries that we have loaded into the controller. For example, we have 6 logic kits, which has a number of programming objects for logical programming of the SDC controller. Then in the middle we have a wire sheet. Wire sheet area is where we actually do the programming, and we can do a multiple folders, so we can split the programming across multiple windows called folders. On the right hand side we have properties. So when we highlight the objects on the wire sheet, we can see the properties of those objects. Furthermore, on the bottom of that we have a couple of areas called links and slots. Links are basically the links that are connected to any particular object, and the slots are the input-output slots, the connection points on each of the objects. So what we can do now is to do a simple program using the CPT tool. Let's do a simple program where we have let's say a thermostat object. So we bring a temperature into the controller, and then with the thermostat object, when the temperature drops below the set points, let's say 18 degrees, the output of the controller goes on. So how do we program this? It's relatively simple with the Sedona controllers. So first of all, what we need to do is to bring in the physical input, the temperature, into the controller. So in this case, on the left-hand side, we go to the EasyIO-FG kit. We open the kit, and then we can drag and drop the universal input object to the wire sheet. So once we drag and drop, the object is highlighted. You can see the red line around the objects. And the right-hand side, on the properties field, we can see the properties of that object. So in this case, let's say we select the universal input 2, and the input type is a resistance because we measure the resistance. In our setup, we have installed or connected the PT1000 emulator, which gives a resistance between around 500 and 1500 ohms. Okay, so we got the now universal input measuring the resistance, the temperature, and it's that is now programmed in a wire sheet. Next thing what we need to do is to go to 6 HVAC logic page on the left hand side, and there are a number of objects on the HVAC logic pages. In this case, what we're going to do is we're just going to bring the sensor object to a wire sheet. So we're going to convert the resistance to the temperature. The sensor object selected, so on the right hand side what we need to do is to select the PT1000 object. And the next thing is the connecting the slots between the objects, the inputs and outputs between the objects together. So how do we do that? This is the basic operation what we do with all the programming. So what we do is we go to one of the slots, in this case the output, the resistance, and we just with the mouse button drag and drop it to the input on a sensor object and release. And that allows us to do the connection. So in this case we have an input of the bit over 1000 ohms, and it's at 9 degrees. And if with the simulate we increase the temperature, then basically you can see the resistance is increasing and the temperature is increasing. So how do we do the simple thermostat operation then? As we said, we wanted the digital output to come on when the temperature drops below 18 degrees. It is really simple with the Sedona controllers. What we do is on the left hand side we go to 6 logic kit, and from there we can drop the object called thermostat to the page. And then we link the temperature reading to the measurement on the thermostat. If we highlight the thermostat object, you can see that there is a set point. A number of properties: measurement, which is the measurement, temperature measurement, set point, SP set point, we put it to 18 degrees, hysteresis, how much it has to go basically below or above in order to operate. So let's put it to 1 degrees. The mode, if it's heating or cooling, cooling a thermostat, and then output, which is actually the status of the system. After which we wanted to switch the digital output on the SDG controller. So on the left hand side on the library again, we go to the FG kits and we drag and drop the digital output to the wire sheet, keep it highlighted, and we select the physical channel 1. And then we just take the status output of the thermostat to the input on the digital output. So now we have done a simple program where we are measuring the temperature, going to the thermostat object. When the temperature drops below the set point of 18 degrees, we will bring the physical output on, so we could, for example, switch on the electric heater battery. So if I now on my simulator turn down the temperature, you can see that measurement going down. When it goes below the 18 degrees, output slot of the thermostat object comes through, and now the digital output DO becomes on. Thank you very much.